talking about the law of science, law of science, it's okay. It's me again talking about the law of sines. Now, what I did was I went ahead and worked a couple of problems on the board to save us some time for me fumbling around with a calculator, but I'll talk you all through it. Here's really one viewpoint with mathematics. You've got the unit circle, and you've got the right triangles and so forth, and everything we've done in trigonometry up to this point has been with respect to a right triangle. So the question is, students often say this, well, why do we need law of sines and law of cosines? Well, those are dealing with non-right triangles, the oblique triangles of the world. So quite simply, and this is a very simple explanation, if I had to explain myself in 5 seconds or less, you need the law of sines and law of cosines for triangles that ain't right. That's pretty much it. Now, like I said, if you're an expert or you've got a PhD, I hope you're not watching this video. But it's just me and my little marker. So what I'm going to do is talk about the law of sines today. Law of cosines is coming up. But quite frankly, there's really only 2 situations when you use the law of sines, even though, as you can clearly see, I have 3 of them written across the board. Angle, side angle, and angle, angle, side are pretty much the same thing. What we're saying is angle, side angle. In a triangle, if you know this angle and the included side, you would use the law of sines. In other words, angle, side, angle in that order. Now, angle, angle, side is pretty much saying, hey, if you know 2 angles and a non-included side, so again, angle, angle, side. But I pretty much think they're both the same thing. One technically is a postulate from geometry. One of them is actually a theorem in geometry because it can be proven using the postulate of the other, but not to get confusing. If you know 2 angles of one triangle, and I do apologize for my notation, let's assume these angles aren't the same, so let me use different symbolism. If you know 2 angles of one triangle, then you know what the third angle is. Same thing here. You know what the third angle is going to be. So hence, both of these really are angle, side angle cases. What a lot of students do is they say, well, I try to use the law of sines with everything. And if I can't use it, then I use a law of cosines. That's one way to look at it. Now, this last one, I apologize for writing a dirty word on the board. My bad. It is the angle, side, side. Should be written, I do apologize, as side, side, angle. But I bet you're never going to forget it now. Because of that case right there, things get all crazy. Which is why I like writing it like that, because it reminds me that it's a crazy case. But before we get there, if I have an angle, side, angle case, or actually this is an angle, angle, side case, angle, angle, side, what I do is this. I'm trying to solve the triangle. I never like those definitions or instructions. Solve a triangle. What the heck do you solve? You solve a question. Solving a triangle means that you're finding all the missing angles and sides. So in this particular case, and this is pretty impressive, what we're saying is that if there's a triangle with a 40-degree angle, a 60-degree angle, and a side length of 4 inches, there's only one triangle that you can create with those specifications in that order. So we should be able to find the other sides. So that's pretty impressive. These congruence theorems from geometry are really powerful. So what I did here was use the law of sines that some of us are already familiar with. It's ratios. So what I did was I said the sine of 40 is to 4 inches as the sine of 60 is to b. So with a proportion, a proportion, an equation stating 2 ratios are equal, what we really want to make sure is that we only have one missing value. Now, I use the means extremes property of proportions, but you call it cross multiplication. So I cross multiplied, got this, cross multiplied, got that. I divided both sides by the sine of 40, and then, like I said, I'm not going to waste the time with the calculator, but make sure your calculator that you're using is in degree mode, and please make sure that you follow those order of operations. Some students like putting the numerator in parentheses and the denominator in parentheses. Other students like typing in 4 times the sine of 60, press enter, get that answer, then divide it by the sine of 40, and you get approximately 5.39 inches. So, to find this other piece right here, we're like, oh no, we don't have that angle. But 60 plus 40 is 100, so we know the three angles of any triangle add up to equal 180. So we knew without using trig, but using our basic, theorem from geometry, we definitely see that right there. That's good. So now we can use the same thing again. The sine of 40 is to 4, as the sine of 80 is to c. I cross multiplied, got this, divided both sides by the sine of 40, and then typed in 4 times the sine of 80, enter, divided by the sine of 40, and got 6.13. Solve that triangle using the law of sines. Usually students love the law of sines. It's a pretty simple formula. Notice that I didn't use this entire expanded proportion right here. I just used like one piece of it, So, but now, here's the case that I really think instructors should really focus on, and students especially, because it really shows your understanding of what you've done up to this point. The angle side case. Get your angle side out of my classroom. I've never gotten a chance to say that. So side angle case. There's lots of strange things that happen with this case. You may get no solution. They may give you the conditions that don't create a triangle. For example, I could easily say I have a certain distance, I've got 20 feet, and then I got 3 feet. So I have this angle here, which might be 45 degrees. I've got 10 feet, and then I only give you a 1 foot. There's no way that we can create a triangle with that, with those conditions in that order. So that's one case. We may not get a solution in an angle side case. We may get one solution, or we may get two. And for a lot of my students, they really had a tough time determining when they would get two versus only one. They wouldn't get that second solution. So what I've decided to do is just work it as if it's only a one solution problem. I said the sine of 35 is to 6, as the sine of b is to 8. I cross multiplied, so 6 times the sine of b, 8 times the sine of 35 degrees. I divided both sides by 6, and I was very careful. I typed in 8 times the sine of 35, press enter, divided by 6, and got approximately 0.76. Now, this right here, this is what those of you watching this video need to really ask yourself. When you look at this equation right there, do you see one solution? Do you see two solutions? Do you see an infinite number of solutions? And your thought processes on that really determine how well you've studied trig up to this point. If you're saying, I don't know, then trust me, you haven't learned what you needed to learn prior to this question on, do you see the wind? Do you see this? If you don't see, if I'm confusing you in any way the last few seconds, then like I said, you're spending a lot of time Googling for answers and you're trying to find no, you've got to just really grab it. Because to solve this, we're going to have to use the inverse sine. And we don't even have to do that. All we could say is, well, how many angles, when I take the sine of it, give me that positive 0.76? Now, here we go. We have the unit circle, and we know that sine is positive in the first and second quadrant. So any angle between 0 and 180 degrees could be a possibility for this angle right here. So you're sitting there thinking, okay, I understand that, but also keep in mind this. On the unit circle, that 0.76, keep in mind that for any value up here, this is x, y, it is the sine that is the y value. So over here, there could be another one. Over here, this is negative x, positive y. So what we need to do is find out where's that point on the unit circle, and let me just change it now, where there's some x value, but the y value is 0.76 on the unit circle. It's definitely not one of our 16 points that we try to memorize, but right here, here's negative x, 0.76. Then you're saying, well, you can add 360 to it to get another solution. True that. But keep in mind, we're talking about the three angles of a triangle. Our answers all have to be under 180 degrees. These three angles must add up to equal 180. So we don't have to worry about these infinite number of solutions in the context of this problem. Oh yeah. So what I'm looking at right here is when I take my calculator is never going to give me an answer in this region right here for sine. Because when you use it on the calculator, you're going to type in the inverse sine of 0.76. In other words, second sine on your calculator, which activates the inverse. So in other words, if I take the inverse sine of both sides, these cancel out. So the angle B is equal to the inverse sine of 0.76. And remember with sine, the sine function looked just like this forever and ever, but we restricted the domain from negative pi divided by 2 radians, or negative 90 degrees, to positive 90 degrees. So when we type it into calculator, our calculator is definitely going to, if we have an answer, we're going to get an answer between 0 and 90 degrees because we're dealing with the angle of a triangle. So once we got 50 degrees, keep in mind, we're saying that this triangle could have an angle of 50 degrees, an angle of 35 degrees, so that would be 85. So what's that? 95 more would be 180 degrees. Checking it real quick. So there's our three sides, or three angles of that triangle. But keep in mind that if 50 degrees is one of our solutions, then possibly the other angle in the second quadrant could be a solution that also has a reference angle of 50 degrees, which would be 130 degrees. So could this actually be 130 degrees? And how do you find out if it does work? We simply take 35, add them together, that's 165, 15 degrees more. That could be the solutions there. So we're now getting two different triangles for this. So we need to be really careful. Our first triangle, let me just draw it out real ugly, is 95 degrees, 35 degrees, and 50 degrees. This side is now 8. And then this triangle right here would have this Mac Daddy obtuse angle 130 right there. 35 would still be there. And this would be 15. And then that angle, that side would be 8. And now we could solve each of these triangles because they are both now angle side angle or angle angle side cases where you would only get one solution. Wow. So here's what a lot of my students say. I can't remember these, which is terrible. You can't remember that. Come on. You didn't even try. Write it in permanent ink on your hand and walk around with it for a few days. It'll get stuck in there. But second, when you use the law of sines, if you have to find that missing angle, when they only give you one angle, that's when you got to be very cautious. And once you get another angle, take the supplement of it and see if that angle plus the other one is less than 180. If it is, then you know you got a second solution. If those two angles added together are greater than 180 degrees, you know that this angle side case only gives you one solution. And everything would be hunky-dory. Until next time. The law of sines has a crazy case. It's the angle side case.